Firebird Heating Solutions are world famous for manufacturing high quality, efficient domestic heating boilers since 1980. The company's philosophy is based on quality and reliability, and they have now taken this to a greater level by introducing the most efficient domestic heating boiler on the market, the Firebird Blue Supreme. Not only does the boiler beat market competitors on efficiency, but the Firebird design engineers have designed a boiler that surpasses future European limits on NOx pollutants, and this has been achieved by introducing blue flame technology into this range of boilers. The Blue Supreme is based on the Enviromax model of boilers, in the respect that it has a primary and secondary heat exchanger, but to make the boiler more efficient, a third heat exchanger, an air-to-air heat exchanger, has been included in the model design. This, in effect, basically brings air in for combustion and pre-warms it and heats it prior to being used in the combustion process. The Blue Supreme can be controlled from the central control panel, which has a number of facilities that are now being introduced on all Enviromax range, as well as the Blue Supreme. The digital control panel allows you to switch the boiler off, switch the boiler on, and then control the desired temperature on the control knob. The control box also has a number of other facilities. Pressing the button once will indicate the actual flow temperature. Pressing the boiler twice will indicate the amount of hours run on the burner. The control panel has a number of features. If a fault occurs, a clear error code will be displayed that guides the homeowner or engineer in the direction of rectification. The control panel also has a 3-minute anti-cycling feature and frost protection built in. To meet stringent future NOx reductions set by the EU, Firebird has used the MHG Burner in the Blue Supreme range. By adopting blue flame technology, the company has been able to produce a heating boiler that reduces NOx limits to approximately 65 mg per kilowatt hour. The burner consists of a 90 watt motor and capacitor, a Siemens control box, a spark igniter, and a Danfoss fuel pump. For protection when the burner is operating, a UV photocell is also fitted. To gain inner access to the burner, the cover is removed, 5 quick release screws are released, and the internal part of the burner is removed from its housing. Once the burner has been withdrawn from its housing, access is gained to the ceramic igniters, the mixing disc, and the fan area. The stainless steel nozzle, which is manufactured by a company called Steiner, is unique to this type of burner and is prescribed as being a yearly renewable item. The principle of operation is fairly simple and consistent with any atomized fuel burner that is currently on the market. Fuel is atomized at high pressure through the Steiner nozzle, where it will mix with air that's being produced by the fan and the atomized fuel before being ignited by the spark igniters. Once the flame has been produced, the flame will be concentrated in the area of the elongated blast tube. Hot combustion gases that leave the combustion tube are then recirced back to the suction side through a gap in the blast tube chamber. By doing this principle, the NOx gases are reburnt, which in turn reduces the NOx levels. Also, the extra oxygen that is leaving the blast tube to be recirced back through the gap is being used to produce a blue flame. Commissioning the boiler is a fairly simple process. Air for combustion underneath the air cover is preset at the factory at a setting of 4.5. For recirculating the gases back through the blast tube will also be preset, and we locked in position on position 1 at the factory. Any adjustment is made from the knurled handle set at the side of the airbox. The first step in the commissioning process is to ensure that the combustion chamber pressure is correctly set to 12.5 millibar, as this has an important effect on how the burner recirculates combustion gases back through the blast tube. The test point screw is released and a digital differential pressure gauge is used to record the pressure. Once chamber pressure has been adjusted and set, the CO2 level required for good efficient combustion is then tested and adjusted as necessary. CO2 for this burner is set between 13.5 and 14%. An adjustment is corrected by altering the fuel pressure, which can be expected between 8.5 and 10 bar.